This is going to be a real quick lesson on quadratic functions and how we graph them. A quadratic function is a function with an x squared, basically. That's the basic definition. So, for instance, if we look at the graph of y equals x squared, and just really quickly I'm going to pull it up on the calculator so you can see it. It looks like a U. Think about if I plug in 0 for x, I get 0. If I plug in 1 for x, I get 1. If I plug in negative 1 for x, when I square negative 1, I still get 1. When I plug in 2 for x, I get 4. When I plug in negative 2 for x, I also get 4. So the graph, I guess I won't wait for the calculator to load because this is what it looks like. It looks like that. Now remember, we talked about graphing absolute value functions a while ago. And we talked about how this number was the slope, this moved it left or right, but the opposite way. So if this was x minus 3, then it went to the right 3, and if it was x plus 4, then it went to the left 4. And that moved it up or down. Well, now we're going to talk about the same thing, but with quadratic functions. And the only difference here, h and k are the same as they were here. A is a little bit different because you can't have a slope of a curve, right? The absolute value function was two lines basically put together. Well, this is a curve. So while we can't call this word, we can't say that a changes the slope because you can't change the slope of a curve. What it is going to do is it's going to make it fatter or skinnier. So let's look. Here is the function y equals x squared. Looks like that. When I put a number in front of the x squared, like let's put a fraction, 0.5. That's 1/2, right? Notice that it gets fatter. Okay, and if I put a big number, like let's say 10, a number greater than 1, now it's going to get skinnier. The other thing we have to talk about is these things, h and k. When I put a number in the parentheses, it's going to move the original graph left and right. So for instance, if I go x minus 4 squared, that is going to move the graph 4 units to the right because it's the opposite of the sign inside. So there's the original, and there is today, there's the new. Alright, and the same thing goes for if I put in x plus 4, it would move to the left. The only other thing that could change is if you take x squared and you add or subtract a number. So for instance, this is now going to move the graph down 3 units. The other thing we talk about with this vertex form of a quadratic, which is what this is the vertex. So here you can see the turning point right there, the turning point right there. Another word for turning point is a vertex. And here's how you find the vertex. So let's say we have the graph y equals x minus 2 squared plus 3. Well, we know that that's going to take our parabola and move it to the right 2 units and up 3 units. There is your vertex, this point right here. Vertex is h comma k. It's the number here, but without the sign. So like if this was a plus, then it would be negative 2. Let me show you. The vertex of this parabola is 2, 3. The vertex of y equals x plus 5 squared minus 4. The vertex of that would be negative 5, negative 4. Because it would move left 5, down 4. So that's how you find the vertex. As far as the equation goes, you're going to have to be able to look at a graph and determine if it went left or right, up or down, and if it's fatter or skinnier. But hopefully as we do more of these, that will make more sense. But this is the gist of what your project in class went over.